what's the difference with an equation? You know, with the less than and greater than and all.
Yeah.
What's the difference graphing one of those versus just a regular equation? You can get.
Don't you get like it all like X and Y?
I'm not talking about solid, I'm talking about
Oh.
what's different about graphing
Oh, the
inequality.
open circle, closed circle. Yeah.
Yeah, kinda. But instead of just graphing a line and being done for the day, what did you have to do if it was like less than or greater than? No.
No arrows or the like.
How about the shading above or below for like greater than or less than? Remember that?
I guess we can go.
Putting an S in for the solution set. Okay, remember that? And you talk about open and closed circle. What's the equivalent when you're graphing a line? You can't make an open or closed line. What do we do differently? Like if it's just less than or greater than with no equal to sign, what do you do with your line?
Arrows? No arrows?
Yes, arrows has nothing to do with the question.
Oh, the dotted line or the...
Oh yeah, solid line or dashed or dotted line.
I said that.
You said open and closed circle.
And then I said the line.
That didn't tell me anything.
You just said the line.
Anywho, let's look at an example here. We're going to graph now a system, right? So there might not be shading, completely on one side or the other of a line, right? Because there will be another line in there that might be shaded the other way. And that's where the shading is going to overlap. Right? Does that make sense? Yeah. Well, let's see. Consider this system of inequalities. Determine if, so we got x plus y greater than 10, and y is greater than or equal to 3x minus 5. 3, 8, and 5, 9. Do we know how to check if they're a solution?
Yeah.
Because the 3 goes in for what? 3 is an x, the 8 is the y, and you plug them in, and it's got to make them both true, right? I don't want to do that again. So this one, 3, 8, yes, just to save some time, and 5, 9 is not a solution to that system. It doesn't make them both true. But now they want us to graph them. Now, the bottom one's all right? Isn't that in mx plus b form?
Yeah.
Slope and all that, right? The top one, we could easily get it. Huh?
Yeah.
Yeah, just sometimes. Yeah. It's not mx plus b form. So let's write plus y greater than 10. We could put it in that form, like by subtracting x, yeah, from both sides. Or we could use the intercepts method, couldn't we? Were you here yesterday? Where do you find the x-intercept? Where y is what? 0. So this one's easy. What's the x-intercept? Right? And what's the y-intercept? Put a 0 in for x. Yeah, that was pretty right. So
that makes no sense. I don't know how you get the equal. Yeah, on the greater than, but
I'm just finding the intercepts. I'm finding 2 points to put so I can draw my line. Okay, when it crosses the x-axis, and don't draw this line. If I have a line that I graphed, right, and here's where it crosses the x-axis, right? It's the x-intercept.
Yeah.
What is the value of y when it crosses the x-axis?
Arrow.
Okay, here's y of 3, y of 2, y of 1, y of 0, right? So wherever anything crosses the x-axis, the y is 0.
What you do to one side.
I'm not solving it.
He's canceling out the x.
So at the x-axis, the value of y is 0. Now wherever a line crosses the y-axis, the y-intercept, what's the value of x? 0. And so if you go put in a 0, say for y, that's where you find the x-intercept, right? If I put a 0 in for x, that's where I find the y-intercept. Does that make some sense now?
A little bit.
Okay?
That was a really straight line. Greater than
Well,
10. How straight that line is.
No, I'm just trying to find the point where it hits.
Do you see
So
this?
I'm disregarding the inequality right now. I'm just trying to find the point where, I need 2 points to define a line, right?
Look how straight the line is.
You got it, yeah. Yeah, I do this for a living, so I can make some pretty straight lines and decent circles and stuff, right?
Circle.
Okay, let's graph this. Now, first of all, this is a real easy mistake to make, because you're thinking about it. When I graph this, what kind of line will it be?
A dotted. Dotted
Linear.
because it's not fluid.
It's going to be a dashed line, right? So let's go to the x-intercept of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the y-intercept of 10. 1, 2, 3, 6, 7, 8, 9, 10. And then take your straight edge, right? There's our 2 points that make a line. And we want a dotted line. Okay?
Go pass out. Rulers and rings.
Oh, yeah, probably should have those in.
Why do you need a book? Dotted line.
Why that's not.
You got the-
That, this. Yeah, okay. Try that again, I want arrows on it. There we are. No, and it was supposed to be, yeah, I'm gonna,
Why are you laughing?
bye.
There's this guy on TikTok, his name's Mr. Huffner too, and it
He's a
reminds-
fraud.
It reminded me of you because of the like, it's just so funny. Mr. Huffner's not always grumpy.
Now, hang on. I don't want anybody to shade anything yet, but if we were to shade this, which way would it be, below or above?
Above, because it's greater than.
And, well, now be careful. Everybody listen very carefully. Yes, you're correct. But it's above because it's a positive y greater than. Okay?
So it's not going to be below.
So if this was like negative y greater than, then positive y would be less than, right? So you got to be careful when you do these, okay?
What?
Since a positive y is followed by the greater than, we would shade above, okay? But we're going to wait on the shading because I want to put the other one in there first. Just see that right there.
Ah.
So we have y, yep,
So.
greater than or equal to 3x minus 5. What's the y-intercept here? Might as well just do it like that. Negative 5. What's the slope?
Oh, 3.
3 over 1, right? So go graph this thing. 1, 2, 3, 4, 5. 1, 2, 3, 1. 1, 2, 3, 1. Just get a few points for accuracy. That's probably enough. What kind of line now, by the way? Why solid?
Because it's included.
It's got the equal to sign. So. You're funny.
You just say I'm funny.
Yeah.
That's what I said.
I messed up that line, but I'm not good.
You don't think Mr. Red's funny?
No, I don't. He gets all the
It's what? What?
Okay, so we haven't shaded yet, right?
Yeah.
Now, the line we just graphed, the solid one, will we be shading above that one or below that one?
I have no idea. Oh, in the
In the triangle.
in the little tiny.
Just forget that right now. Will we shade this one above or below?
Above.
Above, and the other one will be shading,
Above.
what? Oh, above, yeah, sorry. Both of them above, right? So
Like a little triangle.
this one would be shaded above, this one would be shaded above. So
Oh,
where is the region they have in common to be
the
shaded?
little
And
S.
triangle.
Up in here, right? So this represents,
S. S.
the solution set for this.
That's
Okay?
a little solution set.
Well,
Not that
don't forget it goes on infinitely though too. Just the way the graph ended, right? Okay? And that's also known as a feasible region, like when we start,
A weasel what where?
feasible region,
I'm so done.
when we start doing applications. Okay, so don't forget, know when to use a dotted line, right, and a solid line.
No.
And when you have a system, hold off on the shading till you get them both graphed and figure out where, because, like, you could do that and then make a mess and then not be sure, right? I think it's one, but I say this, if you wanted to shade them as soon as you did it, then you'd have to go back and darken in, I guess, you know, where they overlap, that's fine, as long as it's clear, right? Let's look at this example. On the grid shown below, graph the solution to this system. Okay, I'm gonna let you guys take this one. And this one's in mx plus b form, that's not too bad. What kind of line is this one, x greater than or equal to 2? Oh, you know what, scratch it, come back here.
Right.
We have to label, these.
yes.
Wait, hold on, before you label, stop. Label,
Yeah.
there's a little twist here. Now, this line here came from x plus y greater than 10, right?
Wait, so what is this?
This line, the dotted line, was from this equation, x plus y inequality, greater than 10. But the line itself is the graph of x plus y equals 10, isn't it?
Yeah.
So that's what you put on there, x plus y equals 10, because you're just labeling that line. You notice I didn't use the greater than.
Yeah.
And the other one is the y, what am I?
Equals.
Yeah, so this will be y equals 3x minus 5. Right? So when you label your lines with inequalities, you don't put the inequality in. Because the line itself that you're labeling is what you would graph for the equal. Okay? All right, let's go down to number 2. So go ahead, by the way, x greater than or equal to 2. What kind of line is that? What's the first question you ask? What axis does it cut and where does it cut it? All right, so everybody graph these two, right? Get your shading correct. Everyone's doing that now on their own.
Wait, I have a question. Wouldn't the negative 3.5 be like this sign? Oh my god.
That's your slope, that's your rise over run. Down 3, right 2. Huh?
Would the sign be flipped though?
For what flip?
Because like in the first talk, you're talking about how if it was a negative y.
Oh, no, that's a positive y, isn't it?
Oh.
Yeah. All right, everyone go ahead and graph these. See how we do.
I don't feel
Alright.
safe around
2.
She just said that she's stabbing my elbow, my arm would be gone.
Your elbow would not be able to do that.
Get these graph, guys?
No!
I have to graph, but I don't appreciate it.
Yes, it was. Kind of funny.
Probably.
I was actually going to do that. I might have gone back to having to sit down.
Greater than -2. Oh, I
Okay.
see. I shaded.
New x's. Damn.
Oh my god, I went the wrong way with my line.
Yeah, and let's not forget to label it. This one is x equals 2, and this one is y equals -3 halves x plus 2. All right, everybody hopefully has something that looks like this.
No.
You did the wrong slope
I
probably.
did it.
Did you go down 3, left 2?
Yeah. You put just 2.
See, when you did that, you made them both negative.
You didn't put negative, just 2 on X.
Yeah.
3 halves x,
My line is not.
and that's -2. Yes, thank you. So, give me a point in the solution set. What comma what?
Negative 2, comma 1, 2, 3, 4, 5. Yeah.
Negative 2, 1, 2, 3, 4, 5 up there.
Yep.
Well, that lands on both lines, but it lands on the one that's dotted. So is that a solution to the system?
Yeah.
It lands on the one that's dotted, which means it's not included.
I put it on the other one.
It has to lie in this solution set or feasible region.
Negative 2.
What is that? What do you want? Negative 2. Why don't we just, how about like 0, 1?
That was hard.
That's a solution, isn't it? You guys are trying to hit it right on the lines, yeah? They don't have to be, because that's why you shade that. So how about 0, 1?
What
Right?
about negative 4, negative 4?
No.
Point not in solution.
Oh, not in solution. Negative 4, how about let's pick this one that, Sally.
Sally.
Yeah, I forget.
I look like
Negative
that.
2, 1, 2, 3, 4, 5, is that what you said? That's not in the solution set.
Who are you talking about?
Because it lands on the dotted line. And so it's not included. Okay?
Okay.
It's like open circle, right? So now this, that.
This math class goes fast.
All right, other page.
I hope you don't have homework because I don't have to do this.
This is the
All right, here we go. Which of the following points is the solution to the system value qualities below? Well, you know what you could do?
Okay, I'm a minute, but I'm not doing that because I'm too lazy.
Well, I mean, this is like a multiple choice, so maybe you could graph it on your calculator.
No, I did.
Remember how to do inequalities on the calculator? Did we do that?
Yeah, and
So y is less than or equal to negative, go ahead, do it.
oh my gosh.
Or do it, or you can do it algebraically, whichever.
No, that takes so much time.
Okay,
Yeah.
I'm not sure.
You
what the
hit
computer
control
is.
and equal.
Right, yes. So, yeah, we don't want that. Or like when you get here, you could also hit the delete or backspace, right? And it gives you a choice. That's another way to get there. What was it, less than or equal to?
I don't know.
So the first one. And it's going to do it, switch to relation, I guess, right? Negative 4x plus 2. Negative 4x plus 2.
Oh, let's see.
And now we got to do y. Now I got to do the control equals. It's kind of inconsistent.
Why?
Greater than. Did I put the right sign on that first one?
Yes.
Greater than
I feel like it's wrong.
Yeah.
x divided by 2. I should do this because I don't want it to think I'm putting any. So I'm going to watch what I do.
How
X
about that line?
divided by 2. What line? What line?
Like when you hit delete, and it came up as that thing, right? With those like things and
What?
what? When you hit delete, it came up with the less than equal to.
Uh-huh.
Okay, so
And now you're in relation for the second one?
yeah. So how do I?
So now you got to do, just type in y and then control equals for the inequalities. I'm not sure why it does that, but.
When I did that, it said Yaporax.
Yeah,
Let
fine.
me see.
So which of those points would be in the solution set? Guys,
I don't know.
Yaporax.
is 3 negative 6 in this solution set?
No,
Mm-hmm. Is 3 negative 6 in the solution set?
no.
Where's the overlap, by the way? Wouldn't the overlap be up in here?
Yes.
Okay.
Oh,
Let me get that right. So 1 greater than x over 2 plus 7 and less than or equal to negative 4x plus 2. Yeah, okay. How about 0, 2? Is that in the solution set?
No. Oh, negative 2, 10 is not.
Negative 2, 10?
Yes, it is. Again.
Well, we'd have to expand our thing here, wouldn't we, to see? Let's expand that out. Let's change the Y window to go up higher. Like, it's 10, right? So let's do a Y max of, I don't know, 15. Remember to do that? Menu, window zoom 4, window settings 1. Let's just change the Y max. What did I say, go up to 15 maybe?
Oh, mine
Yeah, I know, I don't want it to be right on the edge of the screen.
mine is already.
Okay, so is negative 210 a solution? 1, 2, 15, 14, 13, 12, 11, 10. Is negative 210 a solution?
Yeah.
One of those should be dotted, by the way.
Switch your. No, it's not. No.
What about 410?
What was the X minimum?
It's just negative 10. I just changed the Y max, that's it.
I don't like.
Hey guys, what about 0, 2? Is that a solution?
Yeah. No.
0, 2. Does it hit that line,
Yeah.
which is solid
But
because
it's
it's
not.
equal?
It's not in the. It doesn't matter. If it's on the line, it's included.
Right. It's that solution region,
Oh. Yeah.
and if the line is solid, including points on that line. If it's a dotted line, it's not including points on the line. It's like up to it. Okay? So the answer is 0, 2. Stop. Okay?
I don't know where you got that,
Okay.
but.
Choice 2. So now we have a system. How many inequalities do we have in this system?
3.
3 of them now, right? So we'll have 3 lines. And by the way, when we start getting like this, we can graph these inequalities. We can also start calling them constraints.
So
When we
what's-
get to a word problem, these will be known as constraints. But anyway, these should be pretty simple. Are these in the system? This is, remember, that's X and that's Y, right? Is negative 1 going to be in this system? Okay, it's got nothing to do with the Y. Is negative 1 less than 4? Okay. Let's just graph them.
Negative 1.
I don't want to go and plug these in, right?
Negative 1's greater than 4.
Let's just do this. Let's just say no, and this one is yes. Again, we can plug them in. Let's get to graphing them, okay?
4.
Find the area of the portion of the XY plane that represents the solution. Well, we need to graph it. Oh, part B is down here. So let's graph these. We don't even need a calculator, do we? How about Y is greater than negative 2? What X does it cut? And where does it cut it? Negative 2. What kind?
Horizontal.
Right. Solid or dashed? Solid, right? So Y of negative 2? That's that one. And which way would it be shaded? Above, but hold on to the shading right now. So no, that one we would shade above. Okay? So now the other one is X is less than 4. Cuts the X-axis at 4, a dotted line, right? Okay, so we do that. So X is less than 4. Like that. And which way would that be shaded? This isn't like up or above or below, right? It's a little different.
Left. That would be shaded left.
It was less than, right? To the left. And the other one is Y is less than or equal to 2X. Okay. What is the what is the Y-intercept of this one?
0.
So B equals 0. Mm-hmm.
2 over 1.
So B, yep, let me do that again, because I'll hit that, and it doesn't really matter. So B equals 0, and M equals 2 over 1, right? Okay, so let's graph that one. When it's 0, 1. All right, okay, let's, and what kind of line? Solid, because of the equal to part. Yeah. And down here. Okay. Now, which way would this line be shaded? Above or below? It's y less than, positive y less than, right? So this one would be shaded to the left, this one's below, and this one's above. So isn't this going to be
Yeah.
our solution set? All the way down here, right? Or feasible region. Okay? And again, I like to hold off on my shading till I can figure out where it's all going to be. You don't have to. If you want to shade as you do each one, just go back and make crystal clear what the overlap region is, okay? Well, they want us to find the area of this triangle, right? Well, let's label our equations. This one was what? What are we going to label this with? Y equals 2x. And this one is what? X equals 4. See, I'm using an equal. And what's this one? Negative 2. Get a label. Okay. Formula for the area of a triangle. What's the formula for the area of a triangle?
Base times
No.
half height. 1/2.
1/2 base times height. So the area of our triangle, what's the base?
What's the delta?
That's a triangle.
Oh.
1, 2, 3, 4, right?
Not delta.
And what's the height?
I don't have a dash.
No. The height is 10, isn't it?
I guess.
Wait, the width is 5, isn't it? 1, 2, 3, 4, 5. It's 5. It's 5. Yeah, you just got to count. That's 5. So our area is 1/2 times 4 times 10. What's half of 4? Times 10. Okay? And part of why does a dashed line of one of the borders not make a difference in terms of the area? Well, whether the points are included or not, even if it's a dotted line, it just represents a boundary, doesn't it? Dotted or solid, it's all just a boundary. Does that make sense? We'll just say that it's just a boundary. Okay? All right. Let's do some readers' questions. Everybody got this? Okay. Moving on. First one. That's a piecewise?
Looks it.
No, it does not.
It's not, but it looks it.
It is not a piecewise function. That is a system of inequalities, isn't it?
Yeah.
Okay? And they want you to graph it, right? Are either of them in y equals mx plus b form?
No.
No, no, but we could easily get them in that form, couldn't we? Let's take the top one. Let's get it in the form we need. Negative x plus 2y minus 4 less than 0. Let's just, you know what? Let's just get it to where we can find the intercepts. Why don't we just get the 4 on the other side? Right, add 4 to both sides, right? Is that okay? Instead of like mx plus b, let's do it the intercept way. So, okay, let's find the x-intercept. What do I put in for y? And what's left? Negative x equals 4. Is that the x-intercept? Huh?
Yes.
No, it is not.
Negative. You have to divide by negative.
X, divide by negative 1, so x equals negative 4. That's my x-intercept. Let's find the y-intercept. Put a 0 in for x. What's left?
It's 2.
2y equals 4, so the y-intercept equals 2. So we can go graph those pretty easily. So x of -4, 2, 3, 4, and a y of 2. What kind of line will it be there, children? Solid or,
Solid.
is that right?
Or no, got it.
Yeah, right, there's no equal to sign. So let's do that.
That is the worst dad in life. And who's wrong?
How many of you drawn? Now, which way would we be shading this one?
I don't know.
Do you see a positive y term here?
Oh, it's
And then the less than following it, so which way would it get shaded? Below, but let's wait on that a little bit. Let's go ahead and put the other one in. Let me go on to this side. Let's do 3, yep. 3x plus 4 plus 4 greater than or equal to 0. Let's put this one in y equals mx plus b form. Yeah?
you.
Solve it for y. What's the problem? What do you want to do first?
-4.
Subtract 4 from both sides, okay. So we get 3x plus 4y greater than or equal to -4. Now what do you want to do? Come on, man. I want to solve it for y. Can't be hung up on solving at this point.
Add
Subtract 3x, you mean, from both sides? 4y greater than or equal to -3x minus 4. And finally what? Divide everything by 4. Do we have to switch the sign or anything here? No. So y is greater than or equal to -3/4 x minus 1. Right? So we can do intercept strapping, or we can do mx plus b. So what's the y-intercept? And then the slope is down 3, 2, 3, right 4. 1, 2, 3, 4. Do it again to be accurate. 1, 2, 3, 1, 2, 3, 4. Is that right? Yeah. What kind of line? What kind of line? Solid. Mm-hmm. I'm waiting now. All right. Which way would that one get shaded? Positive y is followed by what sign? So which way would it get shaded? Above it. The other one, positive y is followed by a less than, so it would be, so this one's getting shaded above, this one below, so it's this little in between region here, right? Okay, there's my solution set. We better label these with original equations, right, or inequalities, equations. So this was -x plus 2y minus 4 equals 0. -x plus 2y minus 4 equals 0. And the other one was, well, that was the wrong one, wasn't it? I labeled it with the wrong one. This one, I just lost track. Okay, no, that's this one. Okay, -x plus 2y minus 4 equals 0, and this one is 3x plus 4y plus 4 equals 0. All right? Trying to get a hang of these? What's that follow-up say? Is he correct about 0, 0 being a solution? Why?
Yes, because it's in the shaded area. Just a solution set.
Right. Correct. Right. Because it lies in the overlap of the shaded area, right? Or it lies in the solution set. Huh? Right. What's the next one there? I think we'll do number 2 and then number 4.
Okay.
So let's look at number 2. So I think I'll let you guys play around with this one, okay? Now, also, like, you could put these in your calculator as like a relation, right? Remember how to get the relation format and the thing? And then get some points to plot and draw your line. That's one way to do it, okay? Or you could do it like I did by either doing the intercepts method. The top one, the intercept method's easy, right? The bottom one, if you add 5, it's an mx plus b, right? So either way. So go ahead, you guys, and graph those two inequalities. Make sure you use the proper line, dotted or dashed, dotted or solid, and whether you can shade above or below. Okay? We'll take a minute and work through this. You did that pretty dark too, so it'll take some erasing. So 2 x plus y greater than or equal to 8. 2x equals 8. So there's my x-intercept for that one. And y equals 4 or 8. Over here to 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. And that'll be a solid line. Here. I'm not going to shade yet. The other one is, let's see, y minus, might as well put that, do this, right? Y-intercept the 5, and then up 3 over 1. And I'm running out of room, so I'll go down 3, left 1, down 3, left 1, like that. That should be a dotted line, right? All right, so our solid line, which direction would that be shaded? Above, right? And our dotted line would be shaded which way? No, we're doing above or below?
Oh, below.
Below. Right? So this one gets shaded above, this one below, so wouldn't the solution set be out here? Right? Are you guys able to get this? Okay. Is the 0.18 in the solution set? 1, 1, 2, 3, 4, 5, 6, 7, 8. It's right there. Is it?
2.
Why not?
Because it's not included.
No. Because it lands where?
Not included line.
On the dotted line.
And that's not included.
Correct. It's like open circle. All right. Let's do one more real quick. What did I say, number 4?
Yeah.
And there's a major typo in number 4. Fix that.
Make sense of where?
Number 4. So everybody, these are wrong. So I'm going to write down the actual inequalities here, okay? Should be 2y greater than or equal to 3x minus 16 and y plus 2x greater than negative 5. Okay, so cross those out. That's a significant error on that page. Okay, so graph those with the first one. Split everything by 2, right? You got your mx plus b. The second one, you could do intercepts method, or you could put them over your calculator and do the trace thing and find some points to plot. All right, mx plus b, there, James. Put your dot at negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And then go 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Solid line. Everybody agree for this one?
Yep.
But I like to wait on my shading, right, till I get them both in there.
No, I just did both of them.
Okay. And then the other one is y plus 2x greater than negative 5. Well, I'm just going to subtract 2x from both sides. Get an mx plus b form, right? Y greater than negative 2x minus 5. Right? That'll work. So now I go down to negative 5. 1, 2, 3, 4, 5. And then down 2, right 1. Down 2, right 1. And I go up 2, left 1.
What is the test review due?
Monday when the test is, but I want you to start on it. And this will be a dotted line, right? Okay. Hey, that first solid line, which way does it get shaded? There's positive y greater than stuff, so what? Above. And our dotted line gets shaded above. So they're both above. So wasn't the solution set up in here? All right. Okay, and what's the follow-up question to this? And don't forget to label your graph. Why is 6, 1 a solution, is it?
Oh,
1, 2, 3, 4, 5, 6, 1. Here's 6. Negative 7. 1, 3, 4, 5, 6, 1, 2. Why is 6, 1 a solution and negative 6, 7 is not?
So 7 is on the 9.
Yeah, 6, 1 lies on the solid line. Negative 6.
Dotted line. Or something along those lines.
So, okay, we're having systems of inequalities. Again, you don't have to wait for your shading. I like to because it's a little more clear. But if you, again, if you shade them as you do them, make sure you're clear about where that overlap is. Maybe darken it a bit, okay? All right, here we go. Make sure when you put the calculators back, you press them in and you feel a good snap there. If you're not pressed in firmly, they won't charge. So this will be due Friday, and I also want you to start on the test review. Hold on, Tegan.
I think I'm still recording.